Hi, and welcome to the second edition for August of the Amazing World of Psychiatry News Roundup. This edition features a look at two studies investigating the phenomenon of deja vu with some interesting results. First of all, there's a write-up in Psychology Today of a study that's quite novel in the field of deja vu. So deja vu is when we experience something novel but get the feeling we've experienced it before. So we might have gone to a place for the first time and just get a niggling feeling that we've seen it before, that it's very familiar, when in fact it isn't. And the significance of deja vu is that it is very strongly associated with temporal lobe epilepsy. The research supporting that association is very strong and goes back a long way. So those are very robust findings. There's at least one case study in the literature that I could find of a person with schizophrenia having experienced deja vu, but that would be less common. So what the researchers did, which was quite novel, was to do intraoperative stimulation and recording. So let me explain a little bit more about this. People with epilepsy sometimes have to have surgery, so this is a very small percentage of people with epilepsy that's not responding to treatment would have surgical procedures to remove bits of tissue that act as a focus for epileptic activity. And during these procedures, the surgeons would usually stimulate bits of the brain to find out which parts of the brain are healthy tissue, so that they can preserve as much of the healthy tissue as possible. So in this study, the researchers used electrodes to stimulate parts of the brain. They also used intraoperative electroencephalography. Now EEG, which is short for electroencephalography, is a technique to record electrical activity from the brain. The most common approach for doing this is to use surface electrodes placed on the scalp, and in those cases there's a lot of interference from the layers of tissue between the hair and the skin and the actual brain from where you're interested in getting the electrical activity recordings. So in some senses, getting intraoperative recording of brain activity seems to be a really good way of finding out what's actually happening with as little interference as possible. There are some caveats for that, however. So if you're interested in learning a little bit more about EEG, I've just got this video which is just over 3.5 minutes.
Hello, I'm Dr. Ekaterini Klepusniotou and I'm a lecturer at the Institute of Psychological Sciences at the University of Leeds. Today I will be talking to you about electroencephalography, or EEG for a shorter version of that name, EEG standing for electroencephalography. So what is electroencephalography? Electroencephalography is the measurement of electrical activity produced by the brain as recorded from electrodes placed on the scalp. In fact, the neurons we have in our brain, the nerve cells that actually make up our brain, they communicate with each other through electricity, and it is that electricity, that electrical signals, those electrical pulses that we are actually recording with electroencephalography. So basically we use head electrodes that are mounted on a cap to record the electrical activity from our brain, and that can give us information about processing in the brain. And I will explain to you how that happens, how we record and how we interpret those recordings. Now, EEG was invented in 1928 by Hans Berger, so quite some time ago, and Hans Berger was actually the first scientist to record electrical activity from the brain, from a living human being. Now, the method is non-invasive. You may feel, oh God, electrical activity, putting electrodes on the scalp, but actually we're just recording the electrical activity of the brain. We are not inducing any electrical activity. So it's our brain actually creating this electricity, and we are just measuring it, recording it. Now, like electrical activity, the EEG has several frequency bands, and we can actually describe the different waves. They have names and specific frequencies they occur in, and usually they are associated with a specific function. So, for example, we have alpha waves that occur in frequencies from 8 to 13 Hertz. They occur usually more occipitally. Then we have beta waves that occur in frequencies between 13 and 30 Hertz, and they're more parietal and frontal. We have theta waves that occur in frequencies between 4 to 8, and we usually observe those in children or sleeping adults. And we also have delta waves that occur from frequencies 0.5 to 4 Hertz, and again, those are observed in infants or sleeping adults.
Returning to the study, the researchers were interested in recording and looking at stimulating activity in the hippocampus, the rhinal cortex, and the amygdala. Now, the hippocampus is a really important area of the brain for memory, and so what I'm going to do is just show you a short video on the hippocampus, which is, well, 10 minutes, so if you want to skip it, just fast forward. The hippocampus is a structure in the brain that is shaped like a seahorse. The hippocampus plays an important role in memory. The hippocampus derives its name from the word hippocamp, which in Greek means a combination of horse and monster, and is otherwise known as seahorse. The hippocamps were thought to draw Poseidon through the water and onto land on his chariot.
Okay, good day everybody. So this is where the memory begins and the memory ends. We are talking of the hippocampus. So what we have done here is we have approached the temporal lobe from the inferior aspect, and we are looking at the left temporal lobe, the inferior horn inside the left temporal lobe from the inferior aspect. This is the inferior horn where my finger is, and we can see after we have approached it, this structure that you see here, this is our hippocampus, the left side. The expanded anterior end is the pes hippocampus. This is the body of the hippocampus, and we can, if you follow it further, we can see it will be ending under the splenium of the corpus callosum here, where my forceps, where my probe is disappearing. This whole surface, this shiny thing that you see covering it, is actually the ependyma, which is forming the lining of the inferior horn. And just under that ependyma, we have the alveus, which is nothing but a thin sheet of white matter. And we have already learned that the thin sheet of white matter, that's the alveus, will converge medially. And this converging medial fibers, which we can see here, these converging medial fibers, they constitute the fimbriae. And if you were to follow my probe further, this fimbriae continues up, and it becomes the crus of the fornix. As you can see, my probe is picking it up. My probe is picking up the crus of the fornix. So this is the crus of the fornix, formed by the curving fibers of the alveus. So alveus, fimbriae, crus of the fornix. Hippocampus, head, body, tail, fimbriae, all of it situated in relation to the floor of the inferior horn of the lateral ventricle. Now what I'm going to do is I will make a small transverse section through the hippocampus. Let me reiterate the parts again, just for the sake of completion. The pes hippocampus, the expanded anterior end of the head of the hippocampus, the body of the hippocampus, which forms the floor of the inferior horn, and the tail of the hippocampus, which ends under the splenium. These fibers on the medial aspect are the fimbriae, and the fimbriae continues as the posterior limb of the crux of the fornix, which I have picked up with my probe here. Now let me make a transverse section. When I say transverse section, actually what I mean is, in effect, it is a coronal section through the brain. So let me make a coronal section just to see all the structures, and you will see the seahorse appearance. I have made a coronal section, and we can see that this is the section of the hippocampus. This is a section through the hippocampus, the two sections. The gray matter is buried inside. Normally the gray matter is supposed to be outside, but here the gray matter is inside, and this is the gray matter of the hippocampus. On the medial side, this is the dentate. On the medial side is the dentate gyrus. This is the dentate gyrus. This serrated appearance. This is the dentate gyrus, which is situated on the medial side of the hippocampus. So the dentate gyrus is situated between the fimbrio-dentate sulcus and the hippocampal sulcus. That is the dentate gyrus. So this is all that we can see of the hippocampus at this stage. Now let me try to dissect out the full course of the fornix from this side. What I try to do now is I will trace the fornix all the way from here. I'm tracing the fornix. This is, so to please follow me, this is the fimbriae forming the crust of the fornix, and we can see it is coming here as the body of the fornix. There we go. This is the fornix, and this is how it curves all the way from there, and it comes up here, and it will continue, and it will go all the way around and end here in the mammillary body here. So this is the fornix. Let's trace it again. Let's trace the same thing again all the way from the hippocampus. Fimbriae, posterior column. I am changing the location now. Posterior column, uniting with the opposite side to form the body of the fornix, and this body of the fornix will curve around like this, and it will go around, and it will go behind the anterior commissure and end in the mammillary body here as the mammillothalamic tract. So this is the fornix. So this is the left side which is coming down. So this is all we can see of the hippocampus. With what we had, where we had left off, this is the fimbriae. The fimbriae is continuing up as the posterior column or the crust of the fornix. It winds around this. This is the pulvinar of the thalamus. It winds around the pulvinar of the thalamus, and here it meets with the opposite side, and it forms the body of the fornix. And this body of the fornix then continues under the corpus callosum here, and here this is the body of the fornix, which will continue down, and it will merge in the lateral wall of the third ventricle, and it will end in the mammillary body here, and this is the one which contains the hippocampo-mammillary tract. So we can see it much more clearly in this view now. So okay, that is the end of our demonstration for this.
So returning to the study, the researchers wanted to find out what happened when they stimulated the brain and they got deja vu, and they compared it to occasions when they stimulated the brain and the person didn't experience deja vu. So that was the basis of the study. So what happened when people did experience deja vu was that the researchers found that the three areas of the brain that they were interested in, they had a lot more synchronicity in their firing. They seemed to fire together more than the group who weren't experiencing deja vu. And this is interesting because these areas of the brain are also involved in memory. The amygdala is more involved in emotions, but together they're part of the limbic system, which is a part of the brain that plays an important role in memory. And I've got a possible explanation for these findings, which I'll come on to in a minute. So the second study that I wanted to look at was using virtual reality environments. Now essentially that involves recreating an environment or producing an environment in a computer. Sometimes people wear headsets and have an immersive environment, or sometimes they just look at a monitor and they see this environment, or they see a scene. So what the researchers did was they presented people with scenes, and the great thing about the virtual reality environments is you've got a lot of control over the environments. You can deconstruct them, you can look at them in different ways compared to the real world. So what they found was that when they had research subjects in these virtual reality environments, they tested them on a measure of déjà vu, and when they presented environments which the subjects recognised as novel but had a feeling of déjà vu, the researchers found that this was more likely to occur if the subjects had been presented previously with a scene that very much resembled the novel one that they were being presented with. So if there was some similarity to something that they'd been presented with but weren't able to recall being presented with that previous scene, they would get déjà vu. And this is really interesting because what it's suggesting is that when people are presented with scenes and they can't consciously remember them, they may unconsciously remember them and possibly look at the patterns in the environment. And then when new environments or new scenes are presented, they access these stored memories and link it to the current scene. And this makes a lot of sense in terms of what we know about memories. In fact, I would relate this to research on neural networks, which are computer models or simulations with biological properties of how neurons relate to each other, how learning occurs. And in neural networks, a particularly common form of neural network is the competitive neural network. And what these neural networks do is they complete patterns. So when you present to them lots of information, it might be faces, over and over again, they start to learn patterns, and then when you present them with part of a face, they'll be able to complete it to one that fits the faces stored in their memory. So this might be what's happening with déjà vu, that déjà vu is when someone comes across an environment and it resembles something that's been seen before but not consciously remembered. This neural network perspective is also helpful in interpreting the neurophysiological findings described earlier. So in the intraoperative study, the synchronicity between the brain regions might be because these brain regions, or the brain circuit formed by these different areas, were acting together to pattern complete, to remember, if you like, something that had been stored previously, and that this remembering was triggered by part of the scene that had previously been seen. So these neural network ideas might account for both findings, but of course it's quite speculative. So moving on to other items, the Department of Health has requested the National Institute for Clinical Excellence, the NICE, to create some guidelines for assessing social care quality for people with dementia. And this draft document is now in a consultation phase for registered stakeholders, and that's due to end in the middle of October. Moving on, there's the Skeptical Raptor blog. There's an interesting piece there on how, when you read about new medical treatments, the first port of call should be the Cochrane reviews, and just how excellent these reviews are in looking at the kind of gold standard of evidence out there. So just a timely reminder about assessing new medical treatments and using Cochrane reviews as a starting point. The Smithsonian website has a summary of 10 brain-related studies, so it's quite good, quite nice studies there. And one of them is quite interesting in particular, and that relates to a gene that is acting on other genes, a transcription factor, that is associated with a reduction in brain volume. And it appears to be more likely to be activated in depression. Now this is quite theoretical, but it might link in with some other findings that in some studies in depression there has been an association with reduction in brain volume, and some treatments have been found to reverse this effect. So having a gene that is quite well linked with these other genes and with brain volume reduction and with depression is quite interesting, and there probably needs to be a lot more research into this, and the study is also covered at another place which is linked to on the web page. Moving on, Professor Siris has an article in Current Psychiatry Online just looking at depression and schizophrenia and how to approach that, including the differential diagnosis. And I'll come back to these 2+1 studies in a minute. There's a new research network expansion. This is the New Grid research network, which has given researchers access to brain images when they're studying neurodegenerative conditions, and this is a really ambitious research network. We've already seen some great studies like the Alzheimer's disease neuroimaging initiative, which has produced some really great results, and this is a really truly ambitious research network which is hoping to go global. Okay, let's go back and have a look at these +1 studies. So this is a +1 paper published by some Brazilian researchers. And what they've done is they've basically looked at exposure to organic solvents in petrol-filling attendants. So these are the attendants at garages who fill up the vehicles with petrol, and this is over in the Brazilian petrol stations. They talk a little bit about there being slightly different mixtures being delivered compared perhaps to other areas, which might be a unique kind of consideration. But really what the crux of their study was that when they looked at 25 people who'd been filling up vehicles with petrol, that they looked at 25 of them and compared them to a control group, they found that when they assessed their visual function, there were a number of impairments, and these were things like colour discrimination and visual field acuity. They comment that there's a lot of literature and it's quite divergent, but their findings are quite interesting. I mean, these are some of the graphs that they show. So this is colour confusion index, so this is how well they're able to distinguish or discriminate colours, and going up, I suppose, shows a deterioration in this function, and the stars indicate that it's significant, and you can see that the light grey is the control group, and the black bar other workers. So it is a small study, and it's case control, so it's comparing people at a certain point in time. Now, you can argue that longitudinal studies, where you have two groups at baseline and you follow them up over time, and then you look at these outcome measures in the future, is a slightly better way of trying to tease out cause and effect. So the small sample size and the cross-sectional nature are 2 points to consider. But on the basis of their findings, the researchers have suggested some changes to the regulation of occupational workers' exposure to these solvents. Moving on to the second paper, this is a Norwegian study, and it's looking at the Norwegian Disability Pension Registry. And to cut a long story short, they were looking at people, this is quite a large sample size, this is n equals 77,067, so that's a big sample size. And what they're interested in is seeing who was awarded disability benefits, and how what were the reasons for these awards. So they found the number one reason for disability benefit awards was the musculoskeletal disorders, but actually the second most common award was for mental illnesses, and out of the mental illnesses it was predominantly depression and anxiety. And they also found that when it came to mental illnesses, although they were the second most common reason for the awards, they were associated with more years of awards, in other words, more years when people weren't able to work, and the claimants were younger on average than people with musculoskeletal disorders. So this is another study showing how important it is to... So this is another study showing how important it is to consider common mental illnesses such as anxiety and depression, and that they have a real effect on people's lives and on the economy. So going back to the other news items, this study on Tourette syndrome. Tourette syndrome is a condition where people have compulsions, and they have tics, they have sudden motor movements that are uncontrollable and can cause a lot of distress and suffering for the people and their relatives. And one approach to this has been to try a behavioural intervention, and the researchers in this study compared this behavioural intervention in one group, and they had a control group, and basically there was found to be a significant improvement with the behavioural intervention in 38% of the treatment group compared to only 6% of the control group. And what they found was that this improvement for the treatment group persisted over a longer period of time. So these are encouraging results. Moving on to the next study is a Finnish study, and it is another article in Psychology Today. I found this via Professor Bob's Twitter, and basically what the researchers did was they looked at children aged 7 to 8 and followed them up over a few years in the classroom, and they were interested in this question of what makes learning, what makes education more enjoyable. So what they're saying is a lot of studies have kind of ignored this question about what people actually feel about their emotional experience of learning. So they were very interested in this, and what they did was they went into the classroom and they videoed the children while they were learning, and they talked to them as well, and then they analysed the 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 discussions, and they looked for themes, and they came up with 10 themes from this analysis. And the main kind of ones that I found quite interesting were that the learning experiences were more enjoyable if they were child-centered, if the learning experiences were unhurried, and if the children had an opportunity to be successful at learning tasks as they were learning. And I think it would be really, really great to extend this type of research and to look at adults as well, just to see if these findings are extrapolated. So there's a Dutch study in the British Journal of Psychiatry where they have found evidence of attention deficit and hyperactivity disorder in 3% of their sample, and they were looking at 1,494 older adults in a longitudinal study. They screened them and then invited a subset to more detailed interviews, and on the basis of this they concluded that about 3% of their sample would have ADHD. And ADHD was initially diagnosed in the child and adolescent population and has then kind of been seen in the general adult population. So these are quite interesting findings, suggesting that there might be, some work to be done in the older adult population. The other thing they did was they extrapolated from their findings, and they predict that there's about 95,000 older adults in Holland with ADHD. And just to help you get a better understanding of ADHD, there's this video by the World Medical School, which is a really interesting organisation that's set up to deliver medical education around the world. So it's well worth a look, and this is one of the videos which they've very kindly given a Creative Commons license to this video, which means you can reuse it and remix it, but definitely go and check their YouTube channel out and also their website.
Hi, this is Kendrick Johnson with worldmedicalschool.org. I'm here to talk about ADD, which is a subject that's near and dear to my heart. This is a disease which I share many of the symptoms with Justin Timberlake and Jim Carrey and some of my other friends like, Magic Johnson. Michael Phelps is pretty cool. This is the classic kid who talks too much in class, doesn't listen, doesn't get his homework done, and usually is kind of butting in line and causing problems. It's more common in males and usually presents between 3 and 13 and often runs in families. So the DSM-4 criteria I've kind of simplified here. You got to have these symptoms for at least 6 months, and you got to have 6 symptoms, either in the inattention category or the hyperactivity, impulsivity category, which I'll talk about in just a second. And the symptoms have got to show up before 7 years, and they got to show up in 2 different settings, so at least like school and at home. It can't just be one or the other. And it has to have significant impairment, so it makes it so these kids don't function very well and have problems in social, school, or work settings. And we got to rule out other disorders. So the big numbers to remember are 6 for 6 months, 6 for 6 symptoms, 7 is the age that you got to have impairment by, and it has to be in 2 settings. So the inattention category is the area where the kids have a hard time just paying attention to details. They're making careless mistakes like leaving their name off their paper or not finishing a sentence. Inattention while you're working on homework or playing a game. So the kid might be in the outfield kind of looking at birds instead of watching for the ball to come. And poor listening, even when somebody's speaking directly to them. Doesn't follow instructions, but you got to differentiate this from the oppositional kids who aren't doing it because they don't want to. But these kids may be willing to do the work, but they just kind of forget or weren't listening when they were told to do it. They have trouble organizing activities. Avoids things that take a lot of brain power, at least for long periods of time. Constantly loses things. Often easily distracted, forgetful in daily activities. So these are my symptoms here, but I don't have the hyperactivity symptoms. Fidgeting, getting up from the seat, running and climbing on things you're not supposed to climb on. At times you're not supposed to be doing that. Trouble playing quietly. Parents will say they're always on the go. It's like they're driven by a motor. They talk excessively. Teachers will say they're blurting out answers before the question is done. They don't wait their turn in line. They butt into conversations and into games that they weren't invited to play in. So they end up getting in fights, and a lot of times people don't like them for these things. So the subtypes, there's the predominantly inattentive subtype, and this is what we used to just call ADD, and I don't really understand the rationale for renaming it, because you can have, for example, 7 or 8 inattention symptoms and no hyperactivity symptoms, and you're still called ADHD, which involves the hyperactivity. So I don't know exactly why they did that, but I guess they figure this is all the same disease, even if you don't really have the hyperactive symptoms. And if you have mostly hyperactive symptoms and none of the, or few of the inattentive symptoms, you're the predominantly hyperactive, impulsive type. And the ones that have both categories of symptoms, those are the ones that usually show up early on in life in the doctor's office, because they're driving their parents, their teachers crazy. So on your differential, you got to rule out any kind of mental retardation, whether due to Fragile X or other more subtle mental retardation syndromes. You also need to rule out sensory impairment. A lot of times these kids just don't hear well. You can't see the board, and so it seems like they're not listening. Lead poisoning you don't really see as much anymore. Asthma, I don't know exactly how that ends up looking like ADHD. Thyroid problems, some of these hyperthyroid kids get pretty revved up, or the hypothyroid may have a hard time paying attention. Kids that don't sleep well are not gonna pay attention in class, and the kids with the petit mal seizures are going to blank out for a second, and it seems like they're not paying attention, but they don't even remember it. So ask a few questions when the child comes in, just to make sure that you know how the child is doing in school and at home. Some of the parents aren't going to come in and tell you all these things. So make sure you're asking the questions. The Vanderbilt scale is an improved scale for kind of quantifying these symptoms. So for treatment, behavioral modification is first line if the problems aren't too bad. So this is things like providing a real structure at home. Usually schedule is important here, making sure you're getting up at the same time, going to bed at the same time. Right after school, you go and do your homework before you watch TV. So you keep a real schedule. Also, you keep the home really organized. Everything has a place. try and get some organization in the classroom as well. And a lot of people are associating this with sugar and food additives. There's not really any good research on that. But I have some friends that swear that, what was it, some red food dye. I can't remember the one that was called they talk about, but some red food dye they say is absolutely associated with their kids' ADHD. So it's up to you to try out, but there's no good research for it. The drugs, classically we gave everybody Ritalin. Now I don't hear about people giving as much Ritalin, but more the Adderall, Strattera are pretty common from what I've heard. And so these are all stimulants: methylphenidate, dextroamphetamine, and amphetamine, atomoxetine, pemoline. So these are, basically like meth. They are stimulants. They make your make things go a little bit quicker in your brain, give you more energy in a lot of cases. So those are also in the side effect category too. You can get a little bit irritable, have a hard time sleeping. You don't need to eat as much, so a lot of times the kids will not grow as well. And tic disorders, which are correlated or associated with ADHD, can get worse when you give them these medications. So some of the Tourette's type syndromes can be exacerbated by stimulants. Antidepressants can be used, as well as alpha-2 agonists. I don't know as much about that, but apparently those are also used in treatment, especially if there's some underlying depression as well. And thank you, Carolyn Bonard-Ucci, for your picture of Justin Timberlake. And if you would like to make this a better program, leave your comments below so we can tell other people about the mistakes that are in the video, as well as just suggestions for making it better. You're welcome to say that things that are going well as well, so we can keep doing those. And if you want to share the videos, that will help us to get more people on board so we can make it a better project. And if you want to email at volunteer@worldmedicalschool.org, then there's lots of things that you can do, from PR to website design to research or teaching if you want to. So let us know if you want to help, and thank you. We'll be back with more videos soon.
There's a video by Dr. Creighton Phelps, who's featured on the National Institute on Aging YouTube channel, and again they've made the video available under a Creative Commons license for reuse. And in this video he's discussing some of the changes to the diagnostic guidelines for the Alzheimer's Association over in the States. So he talks you through some of those changes in diagnosis, and also the importance of recognising what I think of as the prodromal phase of mild cognitive impairment. So again, it's well worth checking out both the National Institute on Aging's YouTube channel and also the Alzheimer's Association's website.
The diagnostic criteria are used by clinicians, geriatricians, neurologists, psychiatrists to help ascertain who might have Alzheimer's disease or other dementias or mild cognitive impairment, which is like a pre-Alzheimer's condition. The present guidelines were first formulated in 1984. and have not been revised since then. There has been much research in science since then that has given us new insights to what's happening in the brain. So we needed to incorporate the new knowledge in new guidelines. The changes are minor but important. We now recognize that memory loss is not the only thing that can lead to or be the diagnostic criteria for Alzheimer's disease, but it could be other cognitive functions like attention, confusion, spatial orientation, getting lost in the environment, and so forth. We also now recognize that Alzheimer's doesn't always occur alone, and it could be along with other kinds of dementias or other changes in the brain that weren't addressed in the old guidelines. Doctors will continue to treat patients much like they have in the past because there are no new drugs yet. However, they will be more aware of earlier changes and the possibility that other diseases are contributing to the problems the patient may be having. One of them being mild cognitive impairment, or MCI, which can occur before dementia, and was well known to the research community, but is now going to be probably more available, or the knowledge is going to be more available to the general community. These guidelines are going to have a terrific impact, or a big impact, on research, mainly because it's a paradigm shift of looking much earlier before symptoms occur in Alzheimer's and using biomarkers to identify those people who might be at risk for developing symptoms later. So the earlier we can identify people like that, then research on treatment can start to treat people in these earlier stages.
And now there's a roundup of news items which are relevant to evolutionary psychiatry. Now, I've written an article on this, and basically I think there's probably three things that are going on with evolutionary psychiatry. The first one is talk about genetics and the kind of really detailed kind of mathematical analyses. The second layer is the primatology stuff, which is looking at our nearest relatives, living relatives, including the greater apes, and these are quite important because we do share a number of similarities in terms of our behaviour and in terms of our cognitive abilities. And the third type of study that's relevant is anthropology, which is looking at a number of features of human culture and human behaviour in this wider context, and all of these things can give us some insights into what is pathological and what's not pathological, what's healthy. I think there's a long way to go, so at the moment a lot of this stuff is about kind of trying to find out what the fundamentals are. So the first bit is about Neanderthals, and readers of the blog will probably know that I've got an interest in this area. And it's not really abstract because there's some very good research which is showing that Neanderthals and humans interbred, possibly on several occasions. And the now famous PARBO study from a few years back suggests that most people have about a few percent of their DNA is inherited from Neanderthals. And from the PARBO study, what was really interesting is that they looked at 85 differences, gene differences, between the sample of Neanderthals that they looked at and humans. And out of these, there were a few that were related to illnesses. So I think some of those illness genes are associated with what makes us distinct from the Neanderthals. So anyway, the kind of controversy at the moment is the recent publication of a study that suggests that humans and Neanderthals didn't interbreed. The bottom line is that our common ancestor with Neanderthals that existed hundreds of thousands of years ago could have passed us on the genes which the Neanderthals inherited. And because of the way ancient populations were structured, we just happened to pass these on to subsequent generations, and there was no need for us to include Neanderthal hybridization into this explanation. But there's actually a very good response to this by Professor John Hawkes, which I've linked to on the blog, which kind of really challenges this study. There's a few interesting points about the research. I mean, Professor Hawkes says that there's a lot of data now, so it shouldn't just be a theoretical discussion with a computer model. There should be incorporation of the actual gene data. The second thing is that the paper was on the preprint server for about a year, and in that time there's been another study published which is almost like the sequel to this paper, which finds evidence to again support the hybridization model. So check that post out for the kind of lowdown on this, but the Neanderthal human hybridization is back on. There's another interesting finding, which is that archaeologists have found a 2,600-year-old preserved brain in a body recovered from a peat bog. So human bodies are preserved in wet environments. The Iceman is the most famous example. He's 5,000 years old. Found recovered in ice. Anyway, this is just a really remarkable finding. It's a 2,600-year-old brain which is preserved, recovered from the body, and now what I would really like to see is whether or not the cellular structure, the synaptic connections, are in any way preserved for histological analysis. Although I'm sure that might be a little bit too much to hope for, but if it was, it would make just an outstanding study that I think would have a lot of people very interested. Certainly from just looking at a picture of the brain, the macroscopic features, the sulci and gyri, were certainly present, but there did appear to be a little bit of degeneration there, so I'm not sure how much of it has been preserved. Can chimpanzees use money? Well, there's some evidence to support this. So some groups have been training chimpanzees to use an abstract language, kind of symbol boards and stuff. So what they did was they got some language trained chimpanzees that were able to recognize symbols, and they gave them tokens, and they could exchange these tokens for food. So they are kind of using it as money. And what the interesting finding here was that the chimpanzees would delay their gratification. They would not go for the immediate food, but would hold off if they could have tokens that they could later exchange for food. So basically, maybe at the stage of evolution of chimpanzees, the ability to use money might be there. I'm not sure what nightmare scenario would emerge if chimpanzees did actually start using money. I think there's probably no need for the economy to extend that far. But that's an interesting finding, and of course chimpanzees are our nearest living relatives, and our common ancestor with chimpanzees existed about 6 to 7 million years ago. But it's important to remember that in that time that we shared a common ancestor, that as time has gone on, both humans and chimpanzees have been evolving. Finally, this suggestion from one study that gorillas are able to use motherese. So when mothers talk to their infants, they use a simple language, motherese, and the evidence in gorillas is that they're using a non-vocal form of motherese, that they behave very differently in terms of their gestures and non-vocal responses when they are interacting with infants. So that's a really interesting finding. And basically I'd been to London Zoo to film Tiny the gorilla, who very sadly died shortly after that. But I've included the footage here, which is elsewhere on the TAWOP channel, and you can see some interactions of the mother with the infant, particularly playing with the hands of the infant, holding them up. There's also some slow motion footage just at the end, so don't be surprised if the sound goes off. Alright, thanks for watching.
Uite, papă! Unde e maimuța mică, tata?
Acolo, în iarbă.
Unde?
Stai în iarbă, acolo, tata.
Iarbă? Ce faci?
Stai în iarbă, tata.
În iarbă? Ce faci?
Nu că acolo cu mama ei.
Ia cu mama ei. Ah! Tata, vreau să mă iau la maimuță, tata.
Hai să mergem, să ne uităm la maimuță. Hai, mergem la maimuță.
You can find these stories on the Amazing World of Psychiatry website, which can be found at theamazingworldofpsychiatry.wordpress.com. There are a few things on the website that you won't find here, for instance videos by other people or links to videos by other people, and also there will be hypertext links, so you'll be able to navigate to the source for these news items.